Now we're actually talking about the language of computers. Now remember, computers deal with electricity and electrical circuits, so there are some mathematical operations that we're going to have to cover in order for us to have a deeper understanding and be able to speak the geek, basically. Okay, and one of those things, one of the easiest electrical mathematical manipulations that I like to start off with is something called a NOT gate. Alright? And sometimes this is also called an inverter. Now, in the electrical community, we have diagrams and schematics. And so the way you diagram a schematic, and sometimes you will see this in your textbooks and stuff like that, it will be designed like that. That is an inverter in a schematic. Okay? And basically, whatever you put in voltage-wise, you'll get the opposite voltage. Now, while we're talking about voltage, how do we represent these ones and zeros in electricity? So a lot of people will say, well, a positive voltage will represent a 1, and 0 voltage will represent a 0. But the first thing I like to say is, well, what happens if that cable gets cut, right? There's no voltage on it. Are you going to say you're going to be transmitting a ton of zeros? No. So our electrical engineers, or our double E's, have really come up with a cool idea of not doing this, but have positive voltage represent a 1 and have negative voltage represent a 0. Because you'll either have positive voltage on the line or negative voltage on the line. If the cable gets cut, you'll have no voltage and doesn't represent anything. So that's why when we're talking about a NOT gate, if you put positive voltage on one side of the inverter, it'll invert it to negative voltage. And then if you put negative voltage on the side, it'll bring out positive voltage. Okay? Now how it does that, that's all part of the electrical engineer's job. Right now I just want you to understand what a NOT gate is all about and how to use it in your mathematical manipulations. The other concept that I want to cover is truth tables. Alright, truth tables. And basically, this is one of those things where if I put something on one side, let's say I put a true on this side, I'm going to get a false on this side. So here's my result. And if I put a false on this side, I'm going to get a true on this side. Okay? And so you're going to see schematics, you're going to see voltages, you're going to see truth tables whenever we're discussing about different topics. This seems to be the easiest one that people can actually grasp. And the next one that we're going to be talking about seems to be a little more troublesome for some folks, but I wanted to at least start with a basic understanding. So now let's go ahead and talk about another logical operation in binary. And this is called an AND, or sometimes it's called ANDing, when I'm ANDing one binary number to another binary number. Okay, and of course, you know, everything goes down to electricity, so let's draw what the schematic will look like on an AND. Okay, now great, we know the schematic, but does it really help me understand what it does? So I'm going to draw another picture that I like to use whenever I'm talking about electricity and ANDing. Is basically a line with it's an electrical circuit line that has gaps in it. So this will be the A gap, and then this one will be the B gap. Right? And you know, we can have a little bridge here. Yeah. And if the bridge is down, that means I can cross. If the bridge is up, it means I can't cross. Okay, no Evel Knievel or anything like that, no jumping bridges, although sometimes people swear the electricity jumps and stuff like that. But let's say in the purest form, this is always going to be off if it's not able to cross, or on when it is able to cross. Okay, so now when we're talking about our truth tables or our voltage tables, okay, we'll have an A input on the A side, we'll have an input on the B side, and then we'll have our result. Okay, So if we start off with A being 0 and B being 0, right? So this is 0, 0. Our result is going to be 0. All right? I can't get across A. I can't get across B. Therefore, I'm not getting across. Okay? So let's say, oh, I guess I should have done this. Yeah, that would make a little more sense. Okay. So let's say A is now a 1 and B is still a 0. Okay. If I can get across A, I'm not going to be able to get across B, and therefore I can't get across. So the result is going to be 0. Okay, let's extend this down a little bit. And of course, if the reverse is true, where A is 0 and B is 1, if A is 0 and B is 1, A is 0, which means the bridge is up, and B is 1, which bridges across or down, then I can't get across A, so there's no chance of me being able to get to B, so therefore I can't get across. Okay? And then, if A is on, or the bridge is down, and B is 1, or the bridge is down. Okay, if A is down and B is down, then I'm able to cross A and B, and so I am now able to get across. Okay, now the truth tables is about the same thing. Well, not about, it is the same thing. So A, B, result. If A is true, if A is false and B is false, the result is false. If A is true, B is false, the answer is false. If A is false, B is true, the answer is still false. And then only when A and B are true is my answer true. And that's the basic understanding of what an AND gate is. Okay? We typically use ANDing a lot in the networking field when we're talking about IP addresses. So this is a concept that you're definitely going to want to play more with and understand with and ask me more questions about. The other mathematical process that I'd like to discuss about binary, very common in binary and the use of computers, is something called the OR gate. Okay, when I take a binary number and OR it with another binary number. Okay, and our electrical diagram for that one is going to look like this, with the A and B going to the result over there. Okay, and again, knowing the schematic may or may not help you understand the logic behind it or what is actually going on. So I like to draw something a little more visual, like a little light circuit, to help me understand. I'm a visual person, so I like nice little pictures to help me understand this. So this is the picture that I come up with, A and B, when I'm talking about OR gates. Okay, so again, if we put in our inputs, so we have an A input, we have a B input, and we have a result. Okay, so if A is 0 and B is 0, okay, or if it's false and false, what do we get? So false or 0 means that's up and that's up. Okay, no evil Knievel, so I can't get across there and I can't get across there, so my result is going to be a 0 or false. Okay, now if A happens to be on or true and B is off and false, let's see what happens. So we're going to erase that. And so A is now on, and B is off or false. I can't get across B, but look at this. I can get across A and make it to the end. So my end result is going to be true or on. Okay? And then if the reverse is true, let's say A is turned off or false, B is turned on or true. Let's see what happens. I think you guys can guess before I even draw it out. A is off, B is on. So let's try to go on A. Nope, can't do it. Go across B. Yes, I can, so I can get across. So this value is true. Okay. Now let's turn them both on. So A is on and B is on. So if we turn A on here, and B is already on from the last example, now I can go across either one. To us in the networking field, we don't care which one it goes across. To the double E's, the electrical engineers that are out there, it matters. They know which one that it's supposed to go across. But to us, it can use either path, either or. So we're going to make that one be a true. So as you can see, the results that I get when I OR something is different than I get when I AND something. Okay? So let's go through a couple of examples of how we would AND a binary number and OR a binary number. So this will be our AND example. I can go say ANDing. Alright. Let's do 1 0 1 1 and 1 0 1. Now granted, we're not adding, we're not subtracting, so we're not doing any of these. We're ANDing. Okay, let me clean that up a little bit, get rid of all that, and we're ANDing. Okay, so this is where we go. Is it 1 and 1? So if we go back to our chart, right down here, 1 and 1 was a 1. Now I won't be flipping back and forth all the time. You can freeze frame it or make a photocopy of that or in your own notes or something like that. So in this situation, this is our result of A being a 1 and B being 1. Your result is 1. Okay. The result of 1 and a 0 is going to be false. Nothing there, or 0. Okay. A 0 and a 1, not going to happen, so it's going to be a 0. Okay. A 1 and a 0, because this is a leading 0, again, is a 0. Okay. So as you can see, this isn't addition, this isn't subtraction, this is a mathematical operation or a logical operation. So it's called ANDing. Alright, and this is how we AND something. Okay. Now on this side, let's make sure I'm going to have enough room. We'll just say OR. And I've never really heard it called ORing. I just heard it called OR. So we're going to OR one binary number with another. So let's go ahead and let's do the same numbers and see what we're going to get when we OR them. Okay, and this will be the leading 0. And this will be an OR example. Right? A 0 or a 1 means that I can get through on the result. A 1 or a 0 means I can get through on the result. A 0 or 1 means yes. A 1 or a 0 means I can. So as you can see, ANDing two numbers together is going to give me a totally different number than ORing two numbers together. Okay? And these are logic problems. So when we start using these logics for doing whatever it is that we're doing in the binary, these are the results that we're going to be getting. It's not the same, again, I can't reiterate enough, it's not the same as adding them or subtracting them. It is a different method of manipulating the binary system so that we can get the results that we're looking for, whatever the result it is. ANDing we use a lot of in the networking field, so you're definitely going to need to learn that. ORing we use more in like the programming field and stuff like that. But we do find OR operations other than programming, so it'd be good to have it as one of your tools in your tool belt. Well, that's the basis of the binary numbering system and some common operations on the binary system. So I'd like to thank you for participating in this 10-minute networking workout. Once again, this is Jay Cooper Smith, and happy working out your networks.